one in exactly the same way that we've just done, or we've proved the differentiation of y equals sine to the minus 1x, we can do cos and tan. So let's start with let y equal cos to the minus 1 of x. Okay, we're going to take the cos to the other side, so we've got cos y equals x. Then we differentiate with respect to x. So if you remember, when we differentiate cos, we get minus sine. So we've got minus sine y dy by dx equals 1. So dy by dx equals 1 over minus sine y. Using the same rule that we used on the last one, we know that sine squared y plus cos squared y equals 1. Take the cos squared to the other side, so sine squared y equals 1 minus cos squared y, and then we can square root. So sine y equals the square root of 1 minus cos squared y. Okay, now obviously when we replace that here, we can just move this minus up to the top. So dy by dx is going to be equal to minus 1 over the square root of 1 minus cos squared y. Okay, and in the same way as the last proof, if cos y is x, then cos squared y is x squared. So we've got dy by dx is equal to minus 1 over the square root of 1 minus x squared. Okay, so that's doing the inverse of cos. So if we look now, we can also do the inverse of tan. Starts exactly the same way. So we've got y equals tan to the minus 1 of x. Take tan over to the other side, so tan y equals x. Differentiate with respect to x. Now this one's actually given to you in the formula booklet, you're not expected to know this one, but when we differentiate tan we get sec squared, so that's going to be sec squared y dy by dx equals 1. Dy by dx is going to be equal to 1 over sec squared y. Okay, now this one you may remember from last year, but you should know that 1 plus tan squared y is equal to sec squared y. So we don't actually need to do any rearranging here. This is sec squared, so we can just replace this underneath straight away. So dy by dx is equal to 1 over 1 plus tan squared y. And if tan y is x, then tan squared y is x squared. So dy by dx is equal to 1 over 1 plus x squared. Okay, like I've said, they're all given to you in the formula booklet, but you may be asked to prove them. So you need to remember that we're using differentiation, implicit differentiation, in order to prove those. Okay.